up guys and welcome back to my channel. Today in this video we are going to be interviewing Kari Helgason, the Chief Research at CarbFix, which is a leading company which is fighting against climate change. And what they do to be able to do that is that they capture the carbon in the atmosphere. Sounds pretty cool, right? Why don't we learn more?
CO2 gets dissolved into rainwater. The rainwater seeps through the bedrock all over Earth, and nature slowly transforms the CO2 into stone. And this is a part of the natural carbon cycle that has been happening for many millions of years. And the question was, can we speed it up? We capture the CO2 that's coming from the power plant, and instead of releasing it directly to the atmosphere, we capture it again and inject it as sparkling water.
So here guys, we have the man himself, Kari. And today we are going to be interviewing him, and he is the Chief Officer of Research in, well, CarbFix. But what is CarbFix? Why don't we try to learn more about what Kari does in his life and what is CarbFix in the first place? So, welcome to the show, Kari. I'm really honored and very excited to be with you today. And can you let's just ask you a few questions, and if it's possible, you could just answer them, right? Okay. So, can you share with us your journey into becoming a Chief of Research here at CarbFix?
Oh wow! I'm gonna give you the short version, but thanks Ehsan for having me on. It's a pleasure to talk to you. I am actually an astrophysicist. I study the stars, or studied the stars, and stars and galaxies and black holes and the universe and whatnot. And at some point in my career, I switched my attention from the havens to the underground. I am from Iceland, and what we Icelanders do really well is geology and geothermal exploitation. It's a volcanic island in the middle of the Atlantic, as you know, and we've been using geothermal resources to heat up our houses and our swimming pools and whatnot. And so there's a lot of things going on in terms of geology in Iceland. We have glaciers, we have volcanoes, we have a lot of interesting features. But what I was really interested in was this project that I had heard about called CarbFix, in which scientists managed to turn CO2 into stone underground. So the project, the academic research project CarbFix, was actually ongoing, but then I decided to join them, and it was kind of like a coincidence how I ended up being one of the first 4 employees when the company CarbFix was established. So the technology was commercialized after we knew that it works. And I was one of the first employees there, and one thing led to another, and I became more and more familiar with the technology, being a physicist, and suddenly I was head of research and innovation, and I continue to do that today, which is extremely fun because I get to work with the latest research and knowledge coming out in the field, and also get to test new gadget and innovate and figuring out how to make things better than we do currently.
So you're the one who invents all of these new extraordinary things that CarbFix makes, right? Right. Okay.
But not personally, but yeah, I kind of like I'm involved in everything. I mean, CarbFix now, I told you we started out as 4 people. We're somewhere over 50 now. And there's a lot of people that contribute to new inventions and research that is currently going on within the company. So I'm a part of the team.
Right. And I believe when I was looking at what you were doing, because I was really just inspired of being here today with you, that you used to be in NASA, right? You used to be NASA and in the University of Maryland, right? Right.
Yeah, I was I did my PhD at the University of Maryland, and I worked as a researcher at NASA Goddard Space Flight Center for a while. There I was working on modeling and doing predictions and calculations of what the next generation space telescopes would actually see. And now it's really, really interesting because finally these space telescopes are up there in space, and they're making measurements. So I'm sort of like checking every now and then, like, okay, so what are they actually seeing?
Right, okay.
Does it match what I expected in back when I was doing the
Okay.
calculations? So I'm still kind of like following what happens in the astrophysics space.
All right. And like, what inspired the establishment of CarbFix, and what is CarbFix? We don't really know that.
Yeah. Well, so CarbFix was a project that started out in 2006 as a collaboration between research institutes. There were people from the United States and France and Iceland that came together and decided to test if a theory would work, and that is to use the Icelandic bedrock, or the type of rocks that are very prevalent here in Iceland, to actually use their chemical properties to turn CO2 into stone, solid carbonate minerals. So these solids, we know, happen in nature very, very naturally all over the place, not just in Iceland. For example, CO2 gets dissolved into rainwater. The rainwater seeps through the bedrock all over Earth, and nature slowly transforms this CO2 into stone. And this is a part of the natural carbon cycle that has been happening for many millions of years. And the question was, can we speed it up? Can we actually make it faster? Because nature does it really, really slowly. A span of a human lifetime is very, very short compared to geological timescales. So
right. So it takes like years.
In this crisis, we are now in this climate crisis, and we ain't got no time. So we have to figure out.
You can't just wait for like 4,000 years.
Work quickly.
Right. You can't just wait for 4,000 years or something. You have to make it go.
No, absolutely not. Absolutely not. We cannot even wait for 10 years. So we must start now reducing the CO2 that we are emitting into the atmosphere, and we must also pull a lot of CO2 and carbon out of the atmosphere that we've already emitted.
And I believe actually when I was in Iceland, I was seeing. I went in the. I made a video about it. I went into the geothermal plant. I was really interested. And from what I understood of what CarbFix does, it's that it takes the CO2 from the atmosphere, and then it mixes it with water, and then it puts it into basalt, if I understood. Right. And can you tell us why basalt? Why did we put it in basalt? And why did we mix it with water?
Okay, let's start with the basalt. Basalt is a very, very common rock type on Earth. You can find it in all the continents. It is kind of a young rock that it hasn't been out from the mantle for a very, very long time, and it's still very, very rich in certain metals. That's calcium, magnesium, and iron mostly, and these metals are needed to bind with the CO2. So we provide the CO2, we dissolve it in water, sort of just like a soda stream. So we inject carbonated water or sparkling water.
And then it becomes like sparkling water. Right.
Yes, it is sparkling water, but with the exception that there are no bubbles. So we keep it under pressure. So you don't see any bubbles of CO2 because they're completely dissolved in the water. It's like before you open the sparkling water, you don't see any bubbles. It's not until you open the bottle of sparkling water when the bubbles start to form. So we just make sure that all of the CO2 is completely dissolved in the water, so it has no tendency to rise or escape. And in this way we kind of kill the buoyancy of the fluid. It doesn't want to go up. We inject it down underground, and slowly it reacts with these metals that are released from the basalt, and in time it forms stable carbonate minerals, and it fills up the pore space
So from what I
within the bedrock.
Right, from what I understood, it's that it was going like in those small holes, and trying to and the water, like you were saying, it mixed with the H2O2, and it was a mixing that I put it inside. Okay, right.
Exactly, and also since you mentioned how we get the CO2, we are injecting both CO2 from emission sources. That is, for example, from the power plant itself, we capture the CO2 that is coming from the power plant, and instead of releasing it directly to the atmosphere, we capture it again and inject it as sparkling water. We are also in a collaboration with a Swiss tech company called Climeworks, that has the ability or the technology to actually suck the CO2 out of the atmosphere. They have a first of a kind commercial facility in Iceland, and they're actually building a much bigger one at the moment, which I visited yesterday. It's becoming very, very impressive. But these are sort of like giant CO2 vacuum cleaners that are sucking the CO2 out of the atmosphere, the CO2 that we have already emitted into the atmosphere, and sort of reversing. They're sort of like inverse chimneys, and like giving the CO2 to CarbFix, and then CarbFix dissolves in the water and permanently stores it underground,
and I actually
so that it doesn't contribute to climate change anymore.
When I was trying to learn about CO2 when I was like younger, I remember this company, this Swiss company, which took it, is like, there's some sort of like heat filter, I think. But right, that one, okay. But
and their technology works really, really nicely with geothermal.
It's perfect.
Because they have this kind of filter that they suck the CO2 in, and the CO2 sort of sticks to the filter, and when the filter is saturated with CO2, they close the chamber and they heat up the material so that the CO2 is released.
Okay.
So they use the heat from the geothermal power plant to actually power their operations.
Okay.
And you know, if they would use dirty energy to power their operations, this would be a zero-sum game. It doesn't make sense to actually spend a lot of carbon to power something that pulls the carbon back down. So Iceland is the perfect place to actually test this and scale it up.
Okay. And how do you see innovation playing a role in achieving sustainable utilization of natural resources? So how do you see that the innovation that you're doing right now, how do you see it's playing a role to like help the utilizations and the properties of nature?
I think we are kind of screwed if we don't do innovation, because we sort of know that we do need to innovate and we do need to apply novel technologies if we are to meet the climate goals. And this doesn't only go for CarbFix and carbon capture and storage. It goes for renewables and like all the sustainable energy sector, etc. So it is true that we have a lot of technologies already, and we should start using them and deploying them. But we also know that this is not enough, and we do need to make them better, and we do need to invent.
So you need to like continue and find new ways to make it even faster and faster until we solve our problem with global warming. Actually, about global warming, here's the next question. Global warming is a common challenge for humankind, right? And how important is collaboration on a global scale to solve this?
It is absolutely needed, and we're not going to solve this without collaboration. In fact, if we solve the problem of global warming and we fix the climate, that is going to be a world record in human collaboration across borders. We have never attempted anything like this, a collaboration of this scale. And we should look at this as like a testament to human ingenuity and make it our goal to actually achieve this, because it hasn't been done before. We need to work so cross-border, across like different sectors and across different industries and countries, that it is, and you can see like in the IPCC meetings and sorry the COP meetings that the number of people and stakeholders at the table, it's daunting, but we're still trying to do it because we need to do it, and I mean collaboration is key here. Nobody can solve this on their own. There is no kind of one technology that is going to solve this. It's going to be everything, everywhere, all at once.
All right. So we all need our help. All right. And what are some key challenges CarbFix has encountered in the field of carbon capture? And can you explain to us what is carbon capture?
So carbon capture is a suite of technologies that are able to filter CO2 molecules from other molecules in gas streams and air. So, and people are innovating a lot of different techniques to actually, capture these molecules of CO2. In the atmosphere, the CO2 molecules are very few. For every 10,000 molecules in the atmosphere, you only have 4 molecules of CO2. So there it becomes energy intensive and a pretty hard problem to solve. But carbon capture actually dates back to the 20th century, and we've actually been doing it for quite a while. For example, Norway has been doing it since the 90s. They have been capturing CO2 from gas fields and injecting it for permanent storage. So
I think I remember
there's nothing really new about carbon capture, but it's just lately we've come to realize that it is absolutely needed in the suite of technologies if we are to meet our climate goals. So back in the 90s, it was sort of like, should we use carbon capture or not? Maybe we need it, maybe not. Sounds nice. But, now we're sort of like fast forward to 2024. We have no way in meeting our climate goals without significant carbon capture and storage in the mix. So basically, it's like instead of releasing the CO2 into the atmosphere, you capture it at the chimney.
Right, so you just capture it straight out of the air. Okay. And can you discuss any actually, back to the question that I was trying to ask. Now, can you tell us what are the key challenges that CarbFix is facing by using carbon capture? And carbon capture is I believe when you take the CO2, you store it into a barrel, but you do it differently, of course. But yeah, what have been the challenges of CarbFix in this field?
I mean, there are always some technological challenges. Things never work out as they plan, so we always have to be flexible and replan as we go. For example, we are using water to make the sparkling water and inject it. Now we are trying to use seawater to actually minimize the use of fresh water, which would be extremely important for a lot of places on Earth. So that is one challenge that we're currently working at. That's kind of our flagship research and innovation project at the moment. Some of the other challenges, I would say, are not really technological. They're more related to policy issues.
Right, but what has been the challenges in general? The biggest challenges?
Yeah. So I mean, policy tends to lag far behind the technology, and just policymakers and governments have to understand that we need this, and we need this pretty quickly, and so they must make it.
So it's been visibility, basically.
Quite easily deployable. So if there are too many hurdles in the way, regulatory hurdles, then the scientists are sitting with their hands in the pocket doing nothing but waiting.
Yeah, so the challenge is really getting the visibility and people recognizing you. All right. And can you discuss any cutting-edge technologies or research investments that CarbFix is currently working on to enhance carbon capture solutions?
No, that's all top secret. I cannot say anything about it.
Okay.
No, I'm kidding.
Okay.
What about what we just talked about? Our flagship R&D project, which is actually, instead of using fresh water, we're using seawater. So why don't we do that from the start? Well, number one, our current capture and storage sites are not by the sea, but our next generation storage sites are going to be by the sea, and it would be great if we could use seawater instead of fresh water.
And why?
There are some complications to it because, because we don't want to be competing with freshwater resources of the municipalities and the local communities, for example. Freshwater is becoming ever more scarce in the world. I mean, with climate change, there are going to be places that are extremely dry. But we have enough of seawater. It's kind of an unlimited resource. But the chemistry of actually making the solid carbon minerals with the CarbFix technology using seawater is a little bit more complicated. So we need to research it.
But like, what would be the benefit, right? Or what would be the benefit of using seawater?
Because the resource of seawater is very readily available.
All right.
Nobody is really going to care if we are sucking up seawater. But if we are sucking up freshwater from freshwater reservoirs,
we're drinking
then
that.
people are going to care. Then we're drinking that, and we might be competing with local farmers that are making our food, etc.
So yeah, you want to use it like you want to use resource, which is not like something that you have to use to stay alive, right? Okay. And how was your How was it?
And imagine if you look at the world map. And you sort of map out where are the nicest, basaltic geologies, you will see that, for example, in India, they have a lot of basalts, but they don't have a lot of fresh water.
Right, so that's a good place where you could use it.
Yeah, it's a really good place to use it.
Because there's pollution everywhere there. And there's
a lot of people, a lot of pollution.
Right.
Exactly.
And fresh water is crucial there. Okay. And what is your background in astronomy influence your approach in solving environmental problems, and like how does your background in astronomy help you solve these problems, these environmental problems, and how can you find solutions for them?
Yeah, that's a good question. I'm going to answer it in two parts. One is the romantic version, and the other is the practical version. So the practical answer to this question is like being a physicist with a physics background. It actually helps quite a bit in just like understand the physical sciences and just the way science works. So that helps me tremendously. Number two, I would say like, in the field of astrophysics or astronomy, it really helps you sort of see the big picture. Because when you look at the Earth from space, you don't see any borders. You see one Earth, landmass,
it's one thing.
sea. It's a blue marble in the middle of nowhere, and we have no other place to go.
So you've already been to space. Okay.
Yeah, exactly. I'll send you the pictures afterward.
Perfect.
So we could be alone in the universe for all that we care. I mean, we don't know if there is life elsewhere in the universe. What we know now is that we are not moving to another planet anytime soon. And if we cannot make our own planet habitable, chances are that we're not going to make any other planet habitable.
Yeah, so I guess we'll die.
Yeah. It's kind of this viewpoint that
either we destroy
the Earth, for all we know, is a diamond. It's rare, and we better take care of it.
All right. And where do you see future of carbon capture technologies heading?
Well, I think they're going to get better and better with time. But what I would really like to see is that I would like to see more projects become a reality right now.
Like CarbFix.
Because we need them. Like CarbFix and like other conventional carbon capture and storage projects that are actually injecting in a different way. But I would just like to see more projects. I would like to see them deployed right now because it seems like they are taking a little bit too long a time to
right. So we have to go right now. right now we have to go.
Yeah, and I think where it's heading, we're going to see carbon capture in more industries as well. It's not only going to be like
it's the future. It decides the fate. Right. It decides the fate of the future.
We're going to see it in the metals industry. We're going to see it in the fertilizer industry. So all industries that cannot decarbonize by other means, by implementing new technologies, I would like to see CCS invest.
Right, because it's deciding the fate of the future, right? Yeah. Okay. And our last question of the day. For aspiring people in tech or sustainability space, what advice do you have for them? What's your message to the world who wants to do what you do or want to be focused into the field of carbon capture?
My message is, find your niche in the emerging green tech industry. There's going to be need for not only scientists, but also engineers and policymakers and civil workers. There's a lot of human capital that is needed, and my message would be find your key strengths and apply it to green industries where
trying to use all of our strengths to help the world. Perfect.
Yes, because you don't need to be a scientist to actually make a difference. We all can make a difference.
Thank you very much. I hope that you guys enjoyed this video, and see you next one.